Hi everyone, today we're doing notes for 11.2 permutations. Your dad loves a good dad joke. Here are 6 of his favorites. Want to hear a joke about paper? Never mind. It's terrible. What do you call cheese that isn't yours? Nacho cheese. Why do you never see elephants hiding in trees? Because they're so good at it. Why did the scarecrow win an award? Because he was outstanding in his field. Why don't skeletons ever go trick-or-treating? Because they have no body to go with. What is Beethoven's favorite fruit? A banana. We can use the fundamental counting principle to determine the number of ways these jokes can be delivered. You can choose any one of the 6 jokes as the first one told. Once this joke is delivered, you'll have 5 jokes to choose from for the second one told. Continuing on in this manner, the situation can be shown 6, 5, 4, 3, 2, 1. So we can use the fundamental counting principle to count permutations. So to get our total number of different ways to deliver the 6 dad jokes, we can do 6 times 5 times 4 times 3 times 2 times 1, which gives us 720 ways. So one possible arrangement is the elephant joke, the Beethoven joke, the scarecrow joke, the skeleton joke, the paper joke, and the cheese joke. So permutation is an ordered arrangement of items that occurs when no items is used more than once. So each joke is told exactly once, and the order of arrangements makes a difference. The order in which these jokes are told makes a difference in terms of how they are received. So again, a permutation is ordered. How many ways can the 6 dad jokes be delivered if a food joke is told first? So if I'm talking about food jokes, we have the cheese joke, and then we have the Beethoven joke. So that's 2. Then we have 5 jokes for the next choice, then 4, then 3, then 2, then 1. So this gives us 240 ways. In how many ways can you arrange 5 books along a shelf, assuming that the order of the books makes a difference? I want you to do this one, please. So here we have 5 books. So we're going to do 5 times 4 times 3 times 2 times 1, which gives us 120. An interesting fact, if you were to arrange 16 different books, for example, the 7 books in the Harry Potter series and the 9 books in the Game of Thrones series on a shelf, and it took you 1 minute for each permutation, the entire task would take you 39,807,439 years. So our product in number 2 is given a special name. This is called a factorial, and it's given a symbol. So 5 times 4 times 3 times 2 times 1. You write this as 5. In English, we call that an exclamation mark, but in math, we call it a factorial. So a factorial, if n is a positive integer, then n factorial is the product of all positive integers from n down through 1. So you see it's n times n minus 1 times n minus 2, all the way down times 3 times 2 times 1. 0 factorial by definition is 1. So here we're going to evaluate some of these without using a calculator's factorial key. Now I'm going to tell you where the calculator factorial key is located, even though we're not using it right now. If you hit math on the graphing calculator, then after math, you arrow over to probability, which is PRB. In the probability menu, number 4 is the factorial key. And so you'll find it there. All right, so let's do these. First, we have 9 factorial divided by 6 factorial. So I have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 6 times 5 times 4 times 3 times 2 times 1. Now what's nice is you can see my 1s, 2s, 3s, 4, 5, and 6 all cancel. So this is really like 9 times 8 times 7, which is 504. I would like you to do B, please. 16 factorial divided by 11 factorial. Okay, for this one, we can do 16 times 15 times 14 times 13 times 12 times 11 times 10. Now, we know we're going to keep going because we have 11 on the bottom one, so we don't need to write all the way down to 1 here. Next, we have 11 times 10, etc., all the way down to 1. So we know our 11s, our 10s, and then everything below will cancel. So this is the same as 16 times 15 times 14 times 13 times 12, which is 524,160. Our last example here, we have 100 factorial divided by 99 factorial. So this is 100 times 99 times 98, etc., divided by 99 times 98, etc. So my 99, 98, and everything below cancels, and this is just 100. All right, using the permutations formula. You are the coach of a Little League baseball team. There are 13 players on the team, and you need to choose a batting order having 9 players. The order makes a difference because, for instance, if bases are loaded and a great hitter is 4th or 5th at bat, his possible home run will drive in 3 additional runs. How many batting orders can you form? So we have 13 players. So we have 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5. So we just do the first 9 numbers because we have 9 players, starting with the 13. So if I multiply this out, we get 259,459,200. We can obtain a formula for finding the number of permutations by rewriting our computation. So I wrote this as 13 times 12 all the way down to 1, divided by our 4 times 3 times 2 times 1. So if you notice, what happens is this 4, 3, 2, 1 essentially is what's getting canceled. And so we can write this as 13 factorial divided by 4 factorial. Or this is 13 factorial divided by 13 minus the 9 that were chosen factorial. So again, these numbers come from the 13 players. That gives us our numerator for the 13 factorial. And it also gives us this 13 in the denominator. And we're choosing 9 players. And that's where this 9 comes from. Thus, the number of permutations of 13 things taken 9 at a time is 13 factorial divided by 13 minus 9 factorial. The special notation of 13p9 is used to replace the phrase, the number of permutations of 13 things taken 9 at a time. Therefore, we can write it this way. 13p9 is really 13 factorial divided by 13 minus 9 factorial. So again, a permutation, this is the number of possible permutations of n things taken r at a time, is npr, which is equal to n factorial divided by n minus r factorial. And you can find this in the calculator as well if you hit math. And again, you're going to go to that same probability menu, PRB, and this time the permutation formula is number 2, which it says NPR. And again, I'll highlight our formula here. A corporation has 7 members on its board of directors. In how many different ways can it elect a president, vice president, secretary, and treasurer? So we have 7 members, and this is 4 positions. So we're doing 7p4. And so we have this is 7 factorial divided by 7 minus 4 factorial, which is really the same as 3 factorial. So this is 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1. So my 3, 2, 1 cancels. And this is 7 times 6 times 5 times 4, which gives us 840. You are working for the Sitcom Television Network. Your assignment is to help set up the television schedule for Monday evenings between 6:30 and 9 p.m. You need to schedule a show in each of 5 30-minute time blocks, beginning with 6:30 to 7 and ending with 8:30 to 9. You can select from among the following situation comedies: The Office, That 70s Show, The Big Bang Theory, Married with Children, Modern Family, Cheers, Curb Your Enthusiasm, Seinfeld, and I Love Lucy. How many different programming schedules can be arranged? I want you to do this one, please. Okay, so if we count, we have 9 shows and there are 5 blocks. So this is 9p5. So 9 factorial divided by 9 minus 5 factorial, which is 4 factorial. So we have 9, 8, 7, 6, 5, 4, 3, 2, 1 divided by 4, 3, 2, 1. So my 4, 3, 2, and 1 all cancel. So this is really 9 times 8 times 7 times 6 times 5, which will give us 15,120. The number of permutations of the letters in the name Gia is 3 factorial or 6. So the 6 permutations are, we have G-I-A, we have G-A-I, we have A-G-I, A-I-G, I-G-A, and I-A-G. There are also 6 permutations of the letters of the name Ava. But I'm going to write, it says, are there also 6 permutations of the letters in the name Ava? So I'm going to write this out, but I'm going to distinguish. I'm going to do my first A as orange and my second A as green. So I can write it this first way that we have. We have A, and then I have my V, and then A, the green A. Then I have A, and my V. Next we have V, and then orange A, and then green A. And then I have V, and then green A, and then orange A. And then I have my green A, my orange A, and my V. And then we have green A, V, and orange A. So those are all the different combinations. However, if I look at this, we can see that this one, AVA starting with orange, is really the same as this one, the AVA starting with green. I also have 2 A's and then V, and we also have starting with V. So the answer really is that we have 3 permutations here. Unlike Gia with 3 distinct letters, Ava contains 3 letters, of which the 2 A's are duplicates. So without the use of color to distinguish between the 2 A's, there are only the following distinct permutations. We have AVA, AAV, and VAA. So to find the number of permutations of duplicate items, we are going to take the number of permutations of n items where p items are identical, q items are identical, and r items are identical, and so on. This is given by n factorial divided by p factorial times q factorial times r factorial. So for example, Ava contains 3 letters, n equals 3, where 2 of the letters are identical, p equals 2. So the number of distinct permutations is 3 factorial divided by 2 factorial. So again, we have 3 factorial. This comes from the total letters, and this is divided by my 2 factorial times 1 factorial. The 2 factorial, this represents the A's, and the 1 factorial, this represents the V. So it says, in how many ways can the letters of the word osmosis be arranged? I want you to try this one, please. All right, so in this one, we have 7 letters. We have O, where there's 2, S, where there's 3, M, where there's 1, and I, where there's 1. All right, now, anytime you see a 1, 1 factorial is just 1, so we don't really need to worry about these two. If I wanted to write out the full formula, it would be 7 factorial divided by 2 factorial, 3 factorial, 1 factorial, 1 factorial. But a simpler way to write this is we could write this as 7 factorial divided by 2 factorial times 3 factorial. All right, so this gives us 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 2 times 1 times 3 times 2 times 1. And so this is, we have our 3, 2, and 1 cancel here. I can also cancel, actually I'll rewrite this. This is 7 times 6 times 5 times 4 divided by 2, because we don't need to worry about the 1 here. And now I can reduce the 2 with the 4, make that a 2. So we have 7 times 6 times 5 times 2, which is 420. And that's all we have for today.